Okay, so welcome to tonight's lesson. So start limits, as I earlier on communicated, and this is calculus. Okay, so the first thing we're going to look at when you talk about limits are the rules. We're going to look at the rules that apply when you're dealing with limits. So let's take, for instance, you have L, M, C, and K to be real numbers, meaning they are constants. So if these are real numbers, and then you have a function that has been given, which is f of x as a function, you have the limit of f of x when x is approaching a constant c. So okay, let me just illustrate something here. If you have, for instance, f of x is equal to maybe x plus 2. So if they say find the limit of f of x when x is approaching, let's say maybe a certain number, maybe 3. When x is approaching 3, the answer will simply just be, you get this 3 and replace it there in the expression. So we'll have something like this, 3 plus 2, and then your answer will just be 5. So same applies to g of x. If, for instance, you have g of x here as g of x, for instance, you have g of x here as a function. So if you have g of x the function, g of x function, you have, okay, let me just mute everyone. Okay, so if you have g of x as a function, you're going to have, maybe for instance, you have x squared plus 1 as g of x. So if they tell you to say find the limit when g of x is approaching a certain number c, it means that you're just going to get the number that you've been given there. You replace it while there is x there. So this will simply just be, let's say, for instance, if you've been told to find this when x is approaching a certain constant c, so this will just be equal to, while there is x in this expression, you just have to replace with c. So you have c squared plus 1. So that is what you're going to have as your solution. So if this was a number, would have just replaced that number where there's x there, and then you find the solution. Okay, so let's look at the rules. We'll start with the sum rule. So when you're adding two limits, you have maybe the limit of f of x and then plus g of x. These were supposed to be square brackets. So when you have something like this, when x is approaching c, if the answer after finding the limit of f of x when x is approaching c is L, and the answer after finding the limit of g of x when x is approaching c is M, it means that if you're adding those two functions and then you find the limit as x is approaching a common number, which is c, the answer will just be exactly the same as adding the answers there. It's just the same as adding L and M. So what do they mean? For instance, if you have maybe f of x, the limit of f of x when x is approaching maybe 1 is maybe 3. If the answer that you found is 3, and then for instance, you also have maybe the limit of g of x when x is approaching again 1, the answer will still be, sorry, if the answer maybe is 5 for this one, if they ask you to find the limit or to add the limit of these two functions, if they ask you to find the limit of f of x plus g of x when x is approaching a common number 1, the answer is just the same as adding 3 and 5 there. Just say 3 plus 5, which gives you 8. Okay, so that's what they mean. Same applies to subtraction, which is the difference rule. Subtraction, or rather the difference rule, is just the same as subtracting there. So these rules are just the same. That's what I'm saying. Limits are simple. Multiplication means that you're just going to multiply the answers, L and M. Division, or the constant multiple rule, if you have maybe k as a constant, this k can be any real number. So this when you have this k and it's multiplying with a certain function there, f of x, if the limit of this f of x when x is approaching c is L, it means that you're just going to multiply this L times k. So this can also tell us to say the limit when x is approaching any number here, let's say for instance 3, of any constant, any number. You can have 2, 5, 20, 500, as long as it's any number, any constant, we represent it by the letter k. This is simply just that same number. So if we say the limit of 2 when x is approaching 3, the answer is simply just that same 2. Yeah, so this is what it means. Okay. So the quotient rule, when you divide those two functions, that's the same as dividing the answers. Yeah, so it's just as simple as that. Okay, you also need to understand that there's this special limit, which is the limit of 1 over x to the power n when x is approaching either positive or negative infinity. The answer here is simply just 0. So when you put any bigger number here, you put, let's say, 100 million, you put so n, in short, n is just a number. It represents any bigger number, either negative or positive. The answer will just be 0. It will just approach or it will be moving. The more you increase the value of that number, the more you get closer to 0. So this is going to converge at 0. So what I'm trying to talk about is this: the limit of any number, I mean the limit of 1 over x to the power any bigger number will just converge to 0. So for instance, if you've been given to say, find the limit when x approaches infinity of 1 over x squared. So 1 over x squared, the answer there will just be 0. So same applies to the limit when x approaches infinity of 1 over x. The answer is simply just 0 as well. So same applies to the limit when x approaches negative infinity of maybe 1 over x to the power 5. The answer will still just be 0. Yeah, so this is what it means. Sorry, I said n represents any number. No, I mean x represents any number that is a bigger number, an infinite number in short, not n. Okay, so n can be any integer, either negative or positive. All right, so we have also these special limits here, which you need to master. The limit of sin x over x when x is approaching 0, the answer is just 1 there. The limit of 1 plus 1 over x to the power x when x is approaching infinity, the answer is just e, which is about 2.7 something. And then the limit of e to the power x minus 1 over x when x is approaching 0 is just 1. Same applies to the limit of x minus 1 over ln x. The answer is 1 when x is approaching 1. The limit of 1 plus x to the power 1 over x when x is approaching the positive, is approaching the right hand side of 0. In short, the positive integers. The answer is just e. The limit of 1 minus cos x over x when x is approaching 0, the answer is simply just 0. Okay, so these are special limits that you need to master. Okay, let's look at these examples. I will not solve all the questions here. I'll just pick maybe 1 or 2 questions because it's just a matter of replacing the values that have been given there. So let's look at the first one here. Yeah, so I'll send you a link in which I've solved almost all the questions here. So I'll just pick maybe 1 or 2 questions just for the sake of you knowing what happens when you're dealing with limits. And then when sending the link of this video in the group, I'll also make sure that I add the link for the video where I solved all these questions in that tutorial sheet. Okay, so we have the first one there. They're saying find the limit of 2x squared minus 3x plus 4 when x approaches 5. So the limit of this is found by just replacing. While there is x, we just put 5 there. So you have 2, then you have 5 there, then squared minus 3, and then you have 5 there, then plus 4 there. So we're going to have 5 squared is 25 times 2, that's 50, minus, this will be 3 times 5, 15 plus 4. So 50 minus 15, that should give us something like 35 plus 4, that is 39. So that is how you find the limit of that. And then we also move on to this one. You also do the same. While there's x, just replaced by -2. Even this other one, you also do the same. Where there is u here, we're dealing with u, you just replace with -2. So you say -2 to the power 4, you find the answer plus 3. While there's u, you put -2. So these things are simple. Let's look at this one. Yeah, so these it's just a matter of replacing. So let me solve this one at least. So the limit, yeah, so I'll also tell you one thing. When you're dealing with limits, avoid to have the answer which is undefined. Yeah, so whenever you find the answer is undefined or it's infinity, it means that there's something that you need to do for that limit to become definite or defined in short. So well, imagine if we put 2 where there's x there, we're going to have 2 minus 2, and then any number divided by 0, the answer will be undefined. Hence, we need to do something to this expression. So what can we do? So what you need to do here is to factorize the numerator there. So we factorize the numerator. So we find the factors. The factors, I mean, the product there is -6. The sum is 1. So 2 numbers that we can add to get 1 and multiply to get -6 are simply just -2 and 3. So we're going to replace them there. So we have -2x plus 3x minus 6. We factorize, we have x minus 2, then plus 3, and then we have x minus 2. So we have x minus 2 there, then we have x plus 3. So we can replace while there's this part here in this equation, we replace with x minus 2 and x plus 3. So that's what we're going to do. So we say x minus 2 there, and then we have x plus 3. And then we say divided by, we have x minus 2 there. So you can see that this and that will cancel. Oh, sorry, I forgot to write something. Before we can do that, we have to make sure that we're not leaving this name, limit of x when it's approaching 2. So on top there, we replace with x minus 2, and then x plus 3. Then down, you have x minus 2. So you can see that this and that will cancel. We'll just remain with the limit of x plus 3 when x is approaching 2. So now in this expression, x plus 3, we can now replace while there's x, we put 2. So the answer there will just simply be 2 plus 3. The answer will be 5. So the limit of x plus 3 when x is approaching 2 is simply just 5. So that is how you solve such a question. So if you see that it's giving you undefined when you replace with a number that you've been given there, it means that you have to do something to the function in order to simplify it. Let's also look at this one. So this one, you also do the same. You are going to have x minus 5 on top. Then down there, when you put 5 to be 25 minus 25, which is a 0. So how do you do that? The down part there is a difference of 2 squares, which can be written as this, x minus 5. So you can see that this x minus 5 and that will cancel, meaning that expression can be written as the limit when t is approaching. So here it was supposed to be x, not t. When x is approaching 5 of 1 over x plus 5. So there we just have to replace 5 where there's x, meaning we just have 1 over 5 plus 5, which will just be 1 over 10. Okay, so that's how you deal with limits. So for these other questions, there's a tutorial video which I already made. I think I made it last year. So I'm going to send a link so that you can go through or you can use it for revision. As you are solving, you check, you confirm your answers by checking the same tutorial video. All right, so I've solved all these questions. All right, let's move on. So there's also this question here which says evaluate the following limits. So we have x squared minus 1 and x squared plus 1. So the limit of when this is approaching infinity, so when we replace infinity there and infinity there, it means that the answer that we get is infinite over infinite, which is not making sense. I said when you're dealing with limits, avoid having the answer which is infinite. So how do we deal with this? Remember that expression, that expression that I gave you to say the limit of x when, the limit of 1 over x to the power n when x is approaching positive or negative infinity is simply just 0. So this is the one that we're going to apply on all these questions here. So we start with the first one there. So I'm going to divide. So you look at the functions, the x which has the highest power is the one that I'm going to get. So in this case, all the x that we have, the x's that we have there, they all have the same power. So what does that mean? We're going to divide the whole equation, the numerator and the denominator, by x to the power 2. So we'll have the limit of when x is approaching infinity of x squared divided by x squared, then minus 1 over x squared, and then everything divided by x squared over x squared, then plus 1 over x squared. So the limit of this part, before we even start doing that, x squared over x squared, the answer is 1. So we have the limit when x is approaching infinity of 1 minus 1 over x squared over 1 plus 1 over x squared. So you can distribute this limit. So we can say the limit or when x is approaching infinity of 1, the answer is simply just 1. Remember what I said about the constant, the limit of any constant k when x is approaching any number, it can be any number. So I'll call it that number c. When any number, the answer is simply just that same constant. So the limit of 1 when x is approaching infinity, the answer is simply just 1. The limit of 1 over x squared when x is approaching infinity, the answer is just 0. This is what we've written here. 1 over x to the power n. So the answer is simply just 0. So we say minus 0, then everything divided by the limit of 1 when x is approaching infinity is also just 1. The limit of 1 over x squared when x is approaching infinity, it will simply just be 0. So we're going to have 1 minus 0, which is 1, 1 plus 0, which is 1. And the answer will simply just be 1. So that's the final answer. Okay, so let's quickly move on to the next question. Okay, so the next question is this one. Oh, sorry. Before we move on, let's solve at least another question from this expression. Okay, so I'll also solve maybe this one or this one. At least some, okay, let me solve this one because this one at least the power is 3. So even this one we do the same. We say the limit when x is approaching negative infinity of, so t squared, the highest power is 2 to the power 3. So we're going to divide everything by t to the power 3 plus 2 over t to the power 3, everything divided by t to the power 3 over t to the power 3 plus t squared over t to the power 3 minus 2 over t to the power 3. So when we do the division there, we're going to have the limit when x is approaching negative infinity of, so t to the power 2 over t to the power 3, this will just give us 1 over t. And then 2 over t to the power 3, the answer will just be 2 over t to the power 3. Then everything divided by the first part there, t to the power 3 over t to the power 3, this will give us 1. And then t to the power 2 over t to the power 3, the answer will just give us 1 over t. And then 2 and minus, and then 2 divided 2 to the power 3, we're going to have 2 over t to the power 3. So when you find the limits of all the expressions or independent terms in this expression, it's simply just going to give us, so the limit of 1 over t when x is approaching negative infinity is simply just 0. The limit of 2 over t to the power 3 when x is approaching negative infinity will also just give us 0. And then down there we have the limit of a constant 1 when x is approaching negative infinity, the answer is 1. And then the limit of 1 over t when x is approaching negative infinity, the answer is also just 0. Same applies to the last part there, the answer will just be 0. So when we simplify this, we're going to have 0, 0 plus 0 will give us 0, 1 plus 0, 0, there we're going to have 1. So 0 divided by 1, the answer is 0. So this one is a definite number. So it's correct. The only situation which we need to avoid is finding infinity as the answer. Okay, so this is how you solve these questions. They are very simple and straightforward. So what I was doing here is simply just the same way you find the horizontal asymptote. If they ask you to find the horizontal asymptote of any rational number using calculus, you just simply find the limit of that rational, rational function. When you find the limit of that rational function, when x is approaching either negative or positive infinity, the answer that you are going to get is simply just a horizontal asymptote. So let's quickly check these questions. So we have this question here, which says, for the following curves, determine the horizontal, vertical, and oblique, which is also known as the slant asymptotes, if they exist. So the first one there, the first one we find, let's first start by finding the horizontal asymptote. So to find the horizontal asymptote, we find the limit of this, function when x is approaching, infinite. So this would just be found. Remember what I said, you divide by the highest power, the value of, the term which has the highest power. So the term which has the highest power here is simply just x. So we're going to divide both the numerator and the denominator by x. So we're going to have x over x plus 2 over x, then everything divided by x over x plus 3 over x. So here, I just forgot to write, we have this expression, which is, this limit. So let me just put the equal sign there, and then we have limit here when x is approaching infinite. So of this should be of everything there. So we can simplify that. We have the limit there when x is approaching infinite, and then of x over x, the answer is 1. 2 over x, the answer is simply just 2 over x. Then everything divided by x over x, which is 1. 3 over x, this will be 3 over x. So from there, the limit of a constant number 1 when x is approaching infinity, the answer is simply just 1. The limit of 2 over x when x is approaching infinity, the answer is 0, if you remember what we are just from discussing on the previous page. And then the limit of a constant 1 when x is approaching infinity, the answer is 1. The limit of 3 over x when x is approaching infinity, the answer is 0. So when we simplify this, this will just be 1 over 1, which will just finally give us the answer to be 1. So the horizontal asymptote of this rational function is simply just 1. Yeah, so it's simply just 1. So this is y is equal to 1. Yeah, so y is equal to 1. This is the horizontal asymptote for this rational function. So let us find the vertical asymptote for this same function. So how do you find the vertical asymptote? We get back to normal functions. So you find the vertical asymptote by equating the denominator to 0. So you get the denominator there, x plus 3, you equate it to 0, then the final answer that you'll get will be -3. So this is the vertical asymptote. So this is the vertical asymptote, and then this is the horizontal asymptote. How do we find the oblique asymptote? So the oblique asymptote is sometimes known as the slant asymptote. So now how do you find it? So every time you discover that any given curve has a horizontal asymptote, it means that it doesn't have the oblique asymptote. So since we have managed to find the horizontal asymptote, it means that the oblique asymptote does not exist. And the oblique asymptote only exists when the power of the numerator is higher by 1, is higher, let me say, the degree of the numerator is maybe higher than the degree of the denominator just by 1. What does that mean? So this can only be found if the power, or if the function on the numerator maybe is x squared plus 1 over x plus 2, such that we are able to divide this denominator into the numerator. So the power, rather the degree of the numerator, should be higher by 1 than the degree of the denominator. That's when we can know that it has the slant asymptote. So let's take a look at one example which has the slant asymptote. And then I think that will be the end of today's lesson, because, okay, even these questions that I've left, I've already solved them in a certain tutorial video. I'll send the link to the group. Okay, so this one has, okay, before we can even maybe leave the questions, let's just discuss them one by one. So finding the horizontal asymptote for this one, you just find the limit of this when x is approaching infinity, meaning you divide by x squared in all the expressions there. So but just by looking at this, the horizontal asymptote of this expression is simply just y is equal to 0. How do I know? Because I know that when I divide the numerator there by x squared, because x squared is the highest, I mean, it's the function with the highest degree there. And then we have x over x squared minus 1 over x squared, and then everything divided by x squared over x squared, then plus 1 over x squared. Then we find the limit of this when x is approaching infinity. So when we simplify this, we're going to have 1 over x minus 1 over x squared, everything divided by 1, x over x is 1, and then plus 1 over x squared. So when you find the limit of this when x is approaching infinity, so the numerator there, the top part, the limit of 1 over x when x is approaching infinity is just 0. The limit of 1 over x squared when x is approaching infinity will also just be 0. The limit of 1 when x is approaching infinity is 1 because it's a constant. The limit of 1 over x squared when x is approaching infinity, the answer is just 0. So this will just give us 0 over 1, which gives us 0. Okay. So to find the vertical asymptote, you simply just equate the denominator to 0. So we have x squared plus 1. You equate this to 0. You're going to have x squared is equal to -1. From there, we can say x is equal to the square root of -1. So the square root of -1, when you're dealing with functions other than complex numbers, you say it's undefined, it doesn't exist. So this given rational function, this one here, it does not have the vertical asymptote. So it does not have the vertical asymptote. Okay, so let's quickly move on to this one. So because we found that the horizontal, before we move on to this one, because we found that the horizontal asymptote for this expression is simply just y is equal to 0, it means that it doesn't have the oblique asymptote. That's what it means. Remember what we said, if a function has a horizontal asymptote, it means that the oblique asymptote does not exist for that given function. All right, let's quickly do this one. We do this one, I think we'll call it a day. This is the last slide. The next time when we meet, we'll start the first principle. So for this one, we find the horizontal asymptote. Now, since the degree of the numerator is higher than the degree of the denominator, it means that the horizontal asymptote for this one does not exist. It doesn't exist. Why? try to use the limits. You find that the answer that you find will be undefined. That's the answer you're going to find. Why? Because when you divide everything by x squared, on top there, you're going to have 1 plus 0. Down there, on top, you're going to have 1 plus 0. Down there, you're going to have 0 plus 0. So 1 over 0, the answer is simply just undefined. Once you find this as your answer, it means that the horizontal asymptote does not exist. If the horizontal asymptote does not exist, it means that you can now easily find the oblique asymptote. So now let's first find the vertical asymptote before we go to the oblique. So the vertical asymptote is found by equating the denominator to 0. So the vertical asymptote is simply just x is equal to 1. Then apart from that, we can now find the oblique asymptote. Since we know that it has no horizontal asymptote, meaning the oblique asymptote to be present. So how do we find that? We simply just divide this into that. What do we use to divide? Long division. So we use long division. We have x squared plus 0, x plus 1. Then this side we put the denominator, which is x minus 1. So we start dividing x into x squared. The answer is simply just x. X times x, the answer is x squared. X times negative 1, the answer is simply negative x. So we can subtract x squared minus x squared. The answer is simply x squared minus x squared. The answer is simply 0. Then 0 minus x, the answer is simply positive x, then plus 1. Okay, before I even add the plus 1, let me just do this. Okay, so we have that, and then we can divide. Okay, we can bring down the plus 1 there, the positive 1 in advance. So we can divide this x into that x. The answer will just be 1. So x times 1 times x there, the answer will be x. And then 1 times negative 1, the answer will just be negative 1. Then from there we can subtract. So x minus x, the answer is 0. 1 minus negative 1, the answer will be positive 2. So what you found here is the remainder. So for this one, it's straightforward. You can also use synthetic division. Yeah, it will also work on that one. But synthetic division cannot work on a question like something which has maybe to the power 3 plus x, then down there you have x squared plus 1. You can't use synthetic on this one. But it has the oblique asymptote. So the only way you can find that oblique asymptote is by using long division. That's why I've used long division instead of synthetic. Okay, so this is the remainder there. So the slant asymptote for this given function here is simply just y is equal to, you copy the quotient there, which is x plus 1. The answer there on top, this one, x plus 1, is the that is just the function for, yeah, so that is just the function for the slant asymptote. So the slant asymptote is simply just this one. That is our slant asymptote. Yeah, so it's as simple as that. All right, so this is how you find the vertical, horizontal, and oblique asymptotes using calculus. So see you in the next tutorial. Oh, sorry, not tutorial video. See you in the next lesson that we're going to have. We're going to start discussing the types of, the rules of differentiation. So make sure that you don't miss out that part. That is the most important part in calculus. That's the most important part in calculus. The first principle, yes, it's important, but the rules of differentiation are the ones that are very important. Without knowing those, calculus will be hell to you. It will always be difficult for you. That's the way it is. So make sure that you don't miss the next lecture that we're going to have, which is, I think, will be on Tuesday. It's going to be on Tuesday. Let's come and we discuss the rules of differentiation. We also do the first principle on the same day. All right, so thank you very much. If you have any questions, feel free to ask in the last 4 minutes that we have, before we can close the meeting. Okay, so this means that people have understood. So I'm going to send the recorded session together with the tutorial videos that I talked about for question 1, 2, and 3 that we've solved from the tutorial sheet. See you in the next lecture on Tuesday. Shalom, shalom.